All right, guys, it's me here again, Terry. So I'm going to do some more past paper questions, AdMaths past paper questions on differentiation, right? As I've indicated in previous videos, I do give online classes, right? That's maths. I'm going to start an AdMaths class from August this year. Those are for students entering Form 4 in September, right? I do give online physics classes and chemistry classes, right? I am a past national scholarship winner, right? I'm an electrical and computer engineer, right? And I'm also the sole author of the official Keep Physics Unit 1 and 2 study guides for CXC, right? So the question that I'm going to be looking at here is the June 2014, right? June 2014. All right, so this first question here, we have an equation. The equation of a curve is given by this. So this is my equation of my curve. They're telling us that the point P lies in the curve. Find the equation of the tangent to the curve at the point P, right? So first things first, what we need to do, we need to find the gradient function from the curve. So the curve is y is equal to 3. Y is equal to 3 plus 4x minus x squared. So this is 4x minus x squared, right? And what we need to do, we need to find dy dx, right? That's our differential, right? Or first derivative. So when you differentiate 3, you're going to get 0. Differentiate 4x, you're going to get 4. And when you differentiate minus x squared, you're going to get minus 2x, right? So that's my gradient function. Now, they told us that the point P is 3, 6, right? And that lies on the curve. So the point P, right, is 3, 6. So what we need to do, we need to find the gradient of the tangent at P. So the gradient of the tangent at P, right? What we need to do, we need to take the x equal 3 and substitute it into my differential. So this is going to be dy dx. And what I'm going to do here, I'm going to substitute 3 into this equation, right? Minus 2 multiplied by 3. So this is going to give me 4 minus 6. And this is going to give me minus 2. So that's the gradient of my tangent. So I know the gradient of the tangent, right? And now I want to find the equation of the tangent, right? So to find the equation of the tangent, so the equation of my tangent, right, is going to be y equal to mx plus c, right? That's the general form of a straight line. And we know what the gradient of this tangent is supposed to be. It's supposed to be minus 2. So therefore, y is equal to minus 2x plus c, right? In order to figure out what c is, we need to find this constant. We're going to use the point P in order to do that. So we know that when x is equal to 3, right, y should have been equal to 6. So therefore, 6 is equal to minus 2 multiplied by 3 plus c, right? Make sure that's correct here, minus 2. Right, so this is going to be 6 is equal to minus 6 plus 6. So therefore, c is equal to 6 plus 6. So therefore, c is equal to 12, right? Now, my equation, right, of my tangent is going to be y is equal to minus 2x plus 12, right? But they told us that they want us to write this in this format. Ax plus by plus c is equal to 0. So therefore, it's going to be 2x plus y, right, minus 12 is equal to 0, right? This is the format that they wanted the answer in. So please, you have to write your answer in that format. So that's my answer here for part A, and we get 4 marks for this. In part B now, they gave us a function, right? It's a cubic function, and they want us to find all the stationary points on f of x, right? Now, if you want to find your stationary points, essentially what we need to do, we need to find the differential first, right? At a stationary point, my differential or my dy dx is equal to 0. So let's write down what the function is first. So f of x, right, is equal to 2x cubed minus 9x squared. So this is 2x cubed minus 9x squared, right? Minus 24x plus 7. Minus 24x plus 7, right? Now, because they've given us a function in the form f of x, right? What I'm going to do, I'm going to call this f prime, right? That's another way of writing my differential. If they had given me y is equal to something, then I'll work out dy dx, right? But they've given me it as f of x. So I'm going to write that as f prime of x, right? Now, when I differentiate 2x cubed, I'm going to get 6x squared. When I differentiate minus 9x squared, I'm going to get minus 18x. And then when I differentiate minus 24x, I'm going to get minus 24, right? And when you differentiate a constant, you get 0. So at a stationary point, right, we normally say dy dx is equal to 0, but in this case, since they gave us the function as f of x, I'm going to put f prime is equal to 0. So therefore, I'm going to say 6x squared minus 18x minus 24 is equal to 0. And what I need to do, I need to factorize this. Now, easiest way to factorize this, I can divide everything by 6, first of all, right, to make my life easier. So 6x squared divided by 6, I'm going to get x squared minus, this is going to be 3x, right, minus 4, 6 is that right, that's equal to 0. And what we're going to do now, we're going to factorize this, right? So I'm not going to use any long method to factorize. I'm going to look at it and factorize it by inspection, right? Let's see, you want to get, if I put 1 here, plus 1 minus 4. Let's see if that's correct. X by x will give me x squared. 1 by minus 4 gives me minus 4. And minus 4x, right? So this is what it is here, right? So basically, we can have two values for x, right? So we can say either, right, x plus 1 is equal to 0, and therefore x is equal to minus 1. So that's my x coordinate of one of my stationary point. What I need to do now, I need to find, well, let's find the other value first, the other value of x one time. Or we can say x minus 4 is equal to 0. Therefore, x is equal to 4, right? Now, the question asks for find all the stationary points, right? Now, what we've done there, we found the x values. So what we should do, we should find the y values or the f of x values. So we're going to say when x is equal to minus 1, right? F of x is equal to 2 by minus 1 squared minus 9 by minus, sorry, this is cube here. It's 2x cubed. This is cube minus 1 squared minus 24 by minus 1 plus 7, right? Or notice some space there. Okay, so minus 1 cube is going to give me minus 1. Minus 1 by 2 is going to give me minus 2. Minus 1 squared is 1. 1 by, so this is going to be minus 9. This is going to be plus 24. And this is going to be plus 7, right? So let's work that out here. So that's going to be minus 2, minus 9, plus 24, plus 7, and you're going to get 20, right? So I'm getting 20 here. So therefore, my first stationary point, right, is going to be minus 1 and 20. That's one of my stationary points, right? Now we need to use this other x equal 4 here, right, to work out my y value for the next coordinate. So when x is equal to 4, right? Now I don't have enough space here, so I'm going to work it at the bottom here, right? So I'm going to work it here. So f of 4 is going to be, let's substitute this here. So this is 2 multiplied by 4 cubed minus 9 by 4 squared minus 24 by 4 plus 7, right? So using a calculator to work this out. So 4 cubed is 64. 64 by 2, well, that should be 128. So this is 128 here. And 4 4s are 16 multiplied by 9. You're going to get 144. So this is minus 144, right? And then 24 by 4, that's going to give me minus 96 plus 7. So let us work this out here. So that's 128 minus 144 minus 96 plus 7, right? And I'm going to get minus 105, right? So that's what I'm getting. I'm getting minus 105, right? Right, so therefore this point here, or this coordinate here, the second coordinate of my stationary point will be 4 minus 105, right? So that's the answer for this part here, right? Find all the stationary points, that is what we've done. The last part now, we have to determine the nature. When they say nature of your stationary point, you need to determine if it's a maximum or a minimum point or a point of inflection. Now, so these are my stationary points. It's minus 1 and 20. So one point is minus 1 and 20 as 1 point. My second stationary point was 4 and minus 105. So this was 4 and minus 105, right? Those are my two stationary points. Now, we already worked out f prime, or my first derivative, right? Or dy dx, you can call it that as well if you want. Right? And we had gotten 6x squared minus 18x minus 24. So 6x squared. So this is 6x squared minus 18x minus 24. Right? So what I need to do, I need to differentiate this another time. So that's my second derivative, right? And this is going to be, when you differentiate 6x squared, you're going to get 12x minus 18, right? Now, this is what I'm going to use to determine the nature of my stationary points, right? So what I'm going to say is when x is equal to minus 1, right, f double prime, right, or my second differential is going to be 12 multiplied by minus 1, right, minus 18. 12 by minus 1 is going to give me minus 12 minus 18, right? And this is going to give me minus 30. Now, the fact that this number is negative, right, that tells me that this point here, right, so this point is a maximum, right? That's something you guys need to know. When d2y dx squared, right, is negative, then that stationary point is a maximum. I'm going to do the same thing for the other stationary point, which is x equal 4. So f double prime is going to be equal to 12 multiplied by 4 minus 18. So this is 12 4s 48 minus 18, right? And this is going to give me 30, right? That is positive. So therefore, this point is a minimum, right? All right. So that was June 2014. Now, June 2015 now. Let's see how we're doing this one here. In part A, right? Just give me one second. Hold on. All right. So we want to differentiate this expression here, right? Now it's 2x squared plus 3 in brackets. So it's 2x squared plus 3 multiplied by sine, what is 5x, right? Sine 5x. Now, if you look carefully, right, we need to be able to identify that this here is a product, right? So when we have a product, what we normally do, we say let, right, u equal to the first function here, which is 2x squared plus 3, right? We can differentiate this one time. Du dx, right, is going to give me, this is going to give me 4x, right? And we also need to let, right, v equal to sine 5x, right? Now, you can just go ahead and differentiate this as it is. So you can say dv, right, dx is equal to, when you differentiate sine x, right, you're going to get cos x. But if you have to differentiate sine 5x, it's going to be 5 cos 5x, right? That's how what we get when we differentiate that. Now, let's call, so I'm going to call the original equation they gave us, I'm going to call that y. So this is 2x squared plus 3 multiplied by sine 5x, right? So dy dx, right? Now remember, this is what the product rule looks like. If you have y equal uv and you want to find dy dx, it's going to be u multiplied by dv dx, right, plus v du dx, right? This is what we are making use of. This is our product rule here, right? And basically what we have everything across here in order to substitute into that formula. So I'm going to say u dv dx. So that's going to be 2x squared plus 3 multiplied by dv dx, which is this guy here. So that is 5 cos 5x, right? Plus v du dx. V is across here. V is sine 5x. This is sine 5x, right? And you're multiplying that by du dx, which is this guy here, which is 4x, right? So all we need to do is to just kind of simplify this a little bit. So I'm going to put my constant in front. I'm going to leave this as 2x squared plus 3, right? Cos 5x plus, I'm going to put the 4x in front, plus 4x sine 5x, right? So this is my differential, right? So all we're doing here, we are using my product rule, right? That's what I'm doing here. Now, the second part of the question, they're asking us about stationary points again, right? So they're asking us about stationary points in the second part of this question here, this part B. Find all the coordinates of the stationary point on this curve, right? So the curve is y equal x cubed minus 5x squared. So y equal x cubed minus 5x squared, plus 3x plus 1. Plus 3x plus 1, right? If you want to find the stationary points, the first thing we need to do is to find dy dx. So dy dx, right? If you differentiate x cubed, you're going to get 3x squared. If you differentiate minus 5x squared, you're going to get minus 10x, right? And when you differentiate 3x, you're going to get plus 3, right? And when you differentiate a constant, you're going to get 0. Now, they want the stationary points. So at a stationary point, right, dy dx is equal to 0. That's something you need to know. Dy dx is equal to 0 at a stationary point. So therefore, 3x squared minus 10x plus 3 is equal to 0, right? That's what we have to do. And our next step now is going to be to factorize this, right? So that's going to factorize by inspection. So let's see. Put a 1 here and a 3 here. 3 is a 9. And if I put this, right. So this is what I get when I factorize this, right? So we can either say, So either 3x minus 1 is equal to 0. So therefore 3x is equal to 1, and therefore x is equal to 1/3. So this is the x coordinate of one of my stationary points, right? My second solution is going to be x minus 3 is equal to 0. Therefore x is equal to 3. Now the question wants the coordinates, right? So what we've done, we just only worked out the x value. So what I need to do now, I'm going to say when x is equal to 1/3, right? Y, I'm going to have to substitute it into my original equation, right, guys? So this is going to be 1/3 cube, right? Minus 5 multiplied by 1/3 squared plus 3 multiplied by 1/3 plus 1, right? Now, easiest thing to do here, guys, you can use a fraction calculator, right? Now, this is the calculator that I typically use, right? So all I'm doing here, I am going to, because this can work fractions easily for me. So I'm going to work this out in the calculator. So the first one is 1/3, right? Cube. That's the first thing. 1/3 cube, right? Minus 5x squared. So minus, open brackets, 5 multiplied by 1/3 squared. So this is 1/3 squared, right? Close brackets, equal, plus 3 multiplied by 1/3, 3 multiplied by 1/3, right? And we're going to add 1 to that, right? So I'm getting this answer here, but I'm going to write it as 40/27. So this here is 40/27. So therefore, this point or this coordinate here is going to be 1/3, and this is going to be 40/27, right? That's one of my stationary points. The next thing, we need to find the second stationary point. So therefore, when x is equal to 3, that was our other stationary point, y is going to be equal to 3 cubed minus 5 multiplied by 3 squared plus 3 multiplied by 3 plus 1. So 3 cubed is going to give me 27. 3 is 9 by 5. This is minus 45 plus 9 plus 1, right? And use a calculator for that. 27 minus 45 plus 9 plus 1. And I'm going to get minus 8. So I'm getting minus 8 here. So therefore, this coordinate is going to be 3 minus 8, right? So 3 minus 8 is what I'm getting here. Right? Next thing we need to do, we need to find the nature of those stationary points, right? If you go back to the question here, determine the nature of each of those points, right? Let me just get another blank slide here. Right, so we need to find the nature of the stationary point. So what we need to do, we need to differentiate a second time. So dy dx, so look at this, dy dx, right? That was equal to 3x squared minus 10x plus 3. So this was 3x squared minus 10x plus 3. So you want to find the second derivative. So d2y dx squared, that's what we're working out, is going to be, this is going to be 6x minus 10, right? So that's my second derivative. This is what I'm going to use to determine the nature of my points. So we're going to say when x is equal to, what was the first stationary point? 1/3. When x is equal to 1/3, right? We're going to get d2y dx squared is going to be equal to 6 multiplied by 1/3 minus 10. So 6 by 1/3 here is going to give me 2. 2 minus 10 is going to give me minus 8. So therefore, since I'm getting a negative here, therefore this point, which is, that coordinate was 1/3 40/27, right? Now, because I got a negative here, that is corresponding to a maximum point, right? So that's that point here. Then we need to work the other point now, which was 3 minus 8, right? So when x is equal to 3, we're going to find d2y dx squared again. So d2y dx squared, and that's going to be 6 multiplied by 3 minus 10. So this is 6 is 18 minus 10. That's going to give me 8, right? That's a positive value. So therefore, this point here, which is 3 minus 8, should be a minimum point, right? So when they ask us for the nature of a stationary point, we have to determine if it's a maximum, minimum, or a point of inflection, right? Though point of inflection is not on your syllabus, right? So that is part B. The last part now, part C, they said a spherical balloon. So they gave us a formula for the volume of a balloon, right, which is a sphere, is being filled with air at a rate of 200 cm cubed per second. So what we need to do, so my volume of this sphere is 4/3 pi r cube, and it's being filled. So when I say it's being filled, what they're telling us here, this is the volume. This is how the volume is increasing. So they've given us a value in cm cubed per second. So therefore that is actually dv dt. So this rate of increase of volume, dv dt, is equal to 200 cm cubed per second. So you have to be able to extract information like this from the exam question. So this number here is my rate of increase of my volume. That's dv dt, right? Now they said calculate in terms of pi the rate at which the radius is increasing. So if you want the rate at which the radius is increasing, what they're asking us for here is what is dr dt. That's what the question is asking us for, What is dr dt? And they told us that r is equal to 10 at that point. So here's what we're going to do. The first thing we need to do, we need to find dv dr, right? So we're going to differentiate this volume formula. So dv dr, now the 4/3 pi, this first part here is a constant, right? And all we're really differentiating here is the r cube, right? So the 4/3 pi, that's a constant. You're not touching that, right? So the 3, we're going to bring this 3 to the front, and then we're going to use our formula to differentiate, right? An exponent. So this is going to become squared, right? This could be simplified further, and this is going to give me 4 pi r squared. So this is what dv dr is, right? That's dv dr. The question, if you go back to the question wants us to find dr dt, right? So let's do that. So dr dt, now what we need to do, we need to write an equation, right? This is what we call connected rates of change. So dr dt could be written as dv dr multiplied by dr dt, right? Because if you look carefully, this dr could cancel with this dr. dv dr, we know what that is. We just worked out that. That is 4 pi r squared, right? Multiplied by dr dt. Sorry, by that's not dv dr. Oh, sorry, this is d. I wrote something wrong here. Hold on. Let me just fix this. Hold up. Made a boo-boo here. So the question wants dr dt, right? So it's dr dt, right? That's what we want to find. So therefore, what is required is dr dv multiplied by dv dt, right? So I made a mistake there. So dr dv is actually 1 over 4 pi r squared, right? Multiplied by dv dt. We knew what that was. That's 200, right? So therefore, this is actually 200 over 4 pi r squared, right? This could simplify further. This will be 4 could go into 250 times. So this is 50 over pi r squared, right? But here's what we need to do. They told us that r is 10 centimeters, right? So you're going to say when r is equal to 10 centimeters, right? Dr dt is going to be equal to 50 divided by pi multiplied by r squared. So this is 10 squared. So this is going to be 50 over 10 squared is 100. So this is 100 pi, right? And that 50 can go into 100 2 times. So this is going to be equal to 1 over 2 pi, right? So my rate of increase, right, is going to be 1 over 2 pi, right? Hoping you guys followed what I did there, right? But we should give it a unit as well. It's the radius, so therefore it's going to be centimeter per second, right? That's the rate of increase of my radius, right? So guys, so this was a short video, right? So I did 2 more questions for you guys here on differentiation. As you realize, most of these questions are on stationary points, equation of a tangent. You could be asked to find the equation of a normal as well. All right. So that's it for me, guys. Like I said, I do give online classes for maths, chemistry, physics, and AdMaths will be from August. So my Form 4 classes, my new Form 4 classes will start in August 2021. All right. So take care, guys.